Hi everyone, I'm Xiaoyu.
I'm Alina Desi Hui.
We are from SMJK Ave Maria Convent, Ipoh, Malaysia. Today we'll be presenting our project, Reducing SME Farmers' Intervention
and Increasing the Yield of Oyster Mushroom Cultivation using IoT Application.
This will be a look at the future of oyster mushroom cultivation, especially for SME farmers. This is our team. Our teacher advisor is Pan Humati. I'm Xiaoyu, who will be the live presenter.
I'm Alina, and our team members include Lam Xiaoru and Jacqueline Siu. Humans have been eating mushrooms since primitive ages. Recently, we found out that mushrooms contain high sources of nutrients such as vitamin B, C, and D, and they also have minerals and all 9 essential amino acids. They also have low lipid value and calorific value. Oyster mushroom is one of the most cultivated mushrooms in the world. This is because it requires short growth time, which is about 3 to 4 weeks, and not easily attacked by diseases and pests, while producing high yield and requires low cost.
As oyster mushroom contain high level of nutrients found in both vegetable and meat sources, it will become one of the key to fight famine in the near future. The UN World Food Programme has been teaching women from Zimbabwe to grow grey oyster mushroom as a way to provide them a source of nutrients and income. This proves that oyster mushroom will become a key solution towards SDG number 2, Zero Hunger, especially target number 3, which is to increase the productivity and income of small-scale food producers. As SME farmers in Malaysia are facing difficulty in planting mushrooms, so after we have done our research, we have invented the Smart Mushroom Cultivation Kit to help them increase the yield of oyster mushroom and also to provide them an income while providing Malaysia a local source of nutrients. This is the route map of our project. Firstly, based on the survey done by us, we found that SME farmers in Malaysia are finding difficulties in cultivating oyster mushroom. So, we decided to cite out the factors that are affecting the growth of oyster mushroom. The factors include unsuitable temperature, pH level, and humidity. Besides, it also requires constant monitoring.
After we researched on the suitable parameters for oyster mushroom cultivation, we used IoT application to build our Smart Mushroom Cultivation Kit. It is easy to use and increase the yield of oyster mushroom cultivation. It also helps SME farmers in Malaysia to achieve SDG 2, which is Zero Hunger.
Based on the statistical database of Trend Economy, it is found that continuous decrease of export rate in our country while increase in import rate of oyster mushroom in Malaysia. So, it is sure that the increase in import rate will increase the cost of mushroom, making it less obtainable by citizens. Thus, it will cause a higher risk of hunger or even famine due to poverty.
This is our literature review for our project. Most previous research include the maximum of 2 parameters as factors affecting the growth of oyster mushroom. But in our project, we included the maximum factors such as humidity, temperature, and pH value to produce a better condition for our oyster mushroom.
The objective of our project is to develop a mushroom growing kit to overcome issues related to irrigation, environmental parameter, decreasing yield of oyster mushroom, and also human intervention.
Besides that, it is also to investigate an IoT to monitor crucial factors such as temperature, humidity, and pH. We also want to study ways to minimize human efforts, automate production, and benefit Malaysian SME farmers.
The materials that we use include 3 sensors. The DHT11 sensor is for both humidity and temperature. We also have different sensors for both soil moisture and also pH value. We also use the ESP8266 Wi-Fi model as our hardware with the firmware Node MCO version 1.0 to develop the endpoints IoT applications and connect it to our phone. The Arduino Uno is used to act as the main microcontroller in our project. We also have a DC water pump which is used for irrigation when the humidity is low. Lastly, the 5-volt DC relay model is used as a step-up transformer.
For our software component, we use Link application to allow farmers to easily monitor the criteria and also receive notification when the parameter passes through the threshold. Our app provides a clear view for farmers to see the slight changes in oyster mushroom.
This blockchain diagram shows the methodology used in our project, which includes the sensor section, control section for the main microcontroller, and also the IoT section for our application use. Firstly, the three sensors will receive the data and transfer it to the Arduino Uno before being transferred to the ESP8266 Wi-Fi model.
The data will be transferred to our phone via Wi-Fi connection, and the data will also be generated in the application. It includes 3 buttons for irrigation, switches for DHT11 sensors, and pH medium controller. This is our circuit diagram showing the connections from sensors and water pump to the ESP8266 Wi-Fi module.
So this is our prototype, which is named as the S-Mush kit. So this is the 3 sensors and also the pump, which is situated inside this tank. So this is the DHT11 sensor, which is for the temperature and also the humidity. And for this one, this is the pH sensor, and this will be the interface for the pH sensor. And inside the mushroom kit is our soil moisture sensor. So when you press the button to open the pump, it will automatically flow water. And when you turn it off, it will close. So this is controlled by the button inside the farmer's application. And for the moisture button, when you turn it on, it will detect the moisture inside the substrate. So you will immediately know. When it is too low, it will also send a notification to your email. And for the pH button, it will also detect the pH level. And for now, as we are putting it inside a buffer solution that is pH 4.0, so now you can see it is very accurate. It is nearly 3.98. When it is too low, it will also send an email stating like if it is acidic or it is too alkaline to the farmers. Moving on to our results and discussion. This is our monitoring algorithm. Our project, our smart mushroom cultivation kit, is divided into 3 sensors. One for checking the soil moisture, another to check the temperature and humidity, and lastly to check our pH value.
This is the flow chart when soil moisture is detected. If the moisture level is abnormal, it will send a notification and the user can decide whether to open the pump or not. The problem on irrigation will be solved.
This flowchart shows the circumstances when the temperature and humidity is detected. When the temperature level is abnormal, the lights will be on. When the humidity level is abnormal, the sprinkler pump will be on. If not, it will send a notification to the phone application to show that the mushroom is in suitable condition. This enables us to control the temperature and humidity which is required to obtain higher yield.
This is the flowchart when pH value is detected. Notifications will be sent when the pH value is abnormal. It will show that the substrate is either acidic or alkaline. With this, farmers can carry out early intervention to prevent oyster mushroom wastage due to fungal growth of the abnormal pH of substrate.
In our system monitoring function test, we get analysis data of soil moisture, temperature, and also our pH value. The soil moisture is shown in percentage, while the temperature is shown in degrees Celsius.
Next, the novelty of our project includes revolutionary changes to oyster mushroom farming through monitoring, management, and data analysis, which saves time, energy, and cost, thus making it affordable and sustainable. It can also bring promising return of investment in the shortest period of time, as the yield can also be promising.
Our project also included pH sensor, which is not presented in normal growing kits. This could prevent spoilage and wastage due to soil-borne disease for fungus and bacteria such as molds. It could at least minimize the damage caused by diseases, as we can notice the changes immediately. Thus, our S-Mush kits that we invented based on our research could increase the percentage of yield of oyster mushroom cultivation.
We can conclude that our project is good for pH, moisture, humidity, and temperature for oyster mushroom cultivation. Besides that, It can also successfully detect diseases in the soil by recognizing changes in the substrate. Our project uses IoT-based agriculture for live monitoring to assist SME farmers in increasing their yield by providing them accurate data.
We are sure that it can take efficient care of food production as it provides live feedback for the SME farmers. We hope to help the SME farmers to grow their oyster mushroom with higher yield. In addition to that, our research and invention has contributed to the SDG number 2, Zero Hunger. With that, thank you.